This is compounded interest, and what compounded interest is interest on interest. So when you put money into a bank, at the end of the month, if it's compounded monthly, they calculate what your monthly interest would be, and then they add it right back to your account. So if you put in $500 and you're getting a 12%, it's just a nice percent, then that means every month you would get 1%. Right? So at the end of your month, they go times 0.01, which gives you $5, which means your new account is $5 and $505. And then the next month comes by. So you have a balance of 505. They times it by 0.01 because that's what you get every single month. And you have a new balance of $5.05 plus that. So $5.10. $510.05. So that's all it is. And then the next month they do it again. You have 510.05. They give you another percent, and then they're going to add it on. This is compounded interest. And you could have it compounded annually, weekly, semi-annually, quarterly, monthly, daily, whenever they want. What we were doing is monthly, so you get an interest added to it every single month. If it's annually, they do it once per year. So your balance would stay at $500 for the entire year, and then at the end of the year, they calculate the 12% and add it in. Semi-annually means they do it twice per year. Quarterly means they do it 4 times per year. And then monthly, there's 12 months. That's what we just did. Weekly, they do it 52 times. And then daily, 365. So that means every single day, at the end of the day, they calculate your interest, add it on, and you get a new balance. So these are the formulas. That's the formula for compounded interest. You can also have it compounded continuously, and that's this formula right here. So if you see compounded with an n value, annually, semi-annually, quarterly, you use this. And what do these values mean? Well, A is the amount in the account. It's your balance. P is your principal. It's the amount that you've invested. R is your APR. Don't confuse this with APY, but it's your rate. So your APR. N is the number of times it's compounded. So number of times account is compounded per year. So they're going to compound it 2 times per year because it's semi-annually, 4 times per year. So they're calculating the interest. That's the compounding. And T is time, and it's in years. So all you have to do is go through these problems, pick out the different letters, plug them into the formula, and find the amount in the account. So how much will an account with $5,000 compounded monthly with a rate of 5% have after 5 years? So you just go through P. That's our principal. It's compounded monthly, so our N here is 12. It's our rate of 5%. We can just circle that, but we need to use 0.05. Percentages are not what we need to use. It's the actual number value of it. And then our T is 5. That's it. So if you see compounded, that's giving your N. So we take our formula, A equals P, 1 plus R over N to the NT, and we plug everything in. So 5,000, 1 plus 0.05 over 12 to the 12 times 5. And we only want to enter one exponent, so we cross that off and put 60, because 12 times 5 is 60. Alright, so we plug it into the calculator. So using a basic scientific calculator work, and I don't want parts. You should enter it all at once. So it's 5,000, parenthesis, 1 plus 0.05 divided by 12, parenthesis, and then the caret right here is your exponent key, and that is a 60. And then just hit enter, and there it is. So it's $6,416.79. So $6,416 $16.79. And that's it. So you plug in the values, enter in the calculator, it spits out what you need. All right, try number 2. So you should have gotten that for your formula. And then we bring up the calculator. It's 4,000, parenthesis, 1 plus 0.085 divided by 4 for the compounding. And then exponent key, 12. Make sure I have it right. 4,000, parenthesis, 1 plus 0.045 divided by 12. And then we hit enter. So it's $5,148.07. So $5,148.07. That's it. All right, try another one. This is my favorite just because look at the interest rate. You're going to put $40 in after 30 years. So give that one a shot. Number 3. Hit pause. Go for it. So it's $103,836.75. This is what credit cards are getting from you if you don't pay them off. And that's why high interest rates make a huge difference. But let's just say you could get 28% in your bank account. You invest $40, compounded semi-annually, which is only twice per year. It's all about the rate and the amount of time it takes. So this 30 years is what's doing it. But it's compounded interest. All right, next one is compounded continuously. So we have a new formula. It's A equals P e to the RT. That's this right here. So when you see compounded continuously, your n is gone because we can't do a continuous n. So this is still your P. We know that this is now our new formula. Our interest rate is 0.085 and our time is 3. So we plug all those in, 4,000 e to the 0.085 times 3. And you're going to enter all this into your calculator. So we plug it into the calculator. So we do 4,000. I need more room here. There's the 0. 4,000. Let's clear it out. 4. Try it again. 4,000. And then the E is right here. So you hit the E button. And in parentheses for your exponents, 0.085 times 3. Close the parenthesis, and there it is. So it's 4,000 e to the 0.085 times 3. It did not put the caret in there. I don't know why. There we go. So it's 4,000 times e to the 0.085 times 3. Hit enter, and there it is. So it's $5,161.85. $5,164.85. Let me just double check it again. Yes, so see how it has a 4 and a 6. We have to round it to a 5. So $5,161. And that's it. So different formula, same stuff. So try those two for me. You got a continuous, you got a compounded daily. These are the two formulas. If you can do number 5 and 6, you're good. And there's the answer. So you should have used the continuous formula here and the compounded formula here for daily, weekly, and so on. And those are the answers you should get.